Everyone, I'm Wonli. I introduced simple linear regression model last time. That model includes two parameters, beta 0 and beta 1. So we have to estimate beta 0 and beta 1 from what? From data, of course, right? So now how to estimate that parameters? It is called least squares method. Let's see what least squares method is. Okay, let's take a little review the model here. Okay, simple linear regression model is like this. Beta 0 is intercept, beta 1 is slope of the line. Okay, so we need to take sample, of course, paired sample, y1, x1, y2, x2, yn, xn. Then we get what? Estimated line, linear line, like this. Understand that? Okay, let's see. What least squares method? In a simple linear regression model, the parameters are the intercept and slope, beta 0 and beta 1. To estimate this, let's assume, okay, let's assume we have obtained estimate beta 0 hat and beta 1 hat from the sample, respectively. The estimated line equation is like this. Beta 0 and beta 1 have hat, okay? So we denote y like y hat. Y hat is the sum value on the line. As we have seen in ANOVA, the linear regression model and the corresponding equation obtained from the sample are like this. You remember ANOVA? Yij model is mu plus alpha I plus epsilon ij, something like that. So from sample, this is a model, theoretical thing. But in reality, Yij equal to Y double bar is for mu, alpha I is ith treatment effect. So Yi bar minus Y double bar, okay, plus then Yij minus Yi bar. It is what called residual. This one is realized values for epsilon error, okay? And at that time, we move this term, y double bar, to the left and the square summation, something like that. Anyway, same thing here. Yi equal to beta 0 plus beta 1 xi plus epsilon I. It is small yi. It is what? Estimated value of beta 0, y0 hat, beta 1 hat, xi. What? xi's? They are fixed value, like a constant, not variable. We call variable its name variable, but the values of x are given constant. So beta 1 hat xi, right? Then what is residual? Okay, left and right equality. So yi minus this one, beta 0 hat minus beta 1 hat xi, right? This is values of error. So we call residual. Then the residuals are, let's say, ei equal to yi minus beta 0 hat minus beta 1 hat xi. The method of least square, it is a very famous terminology. So briefly, LS method, something like that. Okay, is the technique used to find beta 0 hat and beta 1 hat. Okay, these we want to know, we want to get these values from sample, say x1, y1, x2, y2, xn, yn. These are sample in this case, paired data. Okay, we know we obtained the values of a sample x1, y1, x2, y2, xn, yn. So unknown value is beta 0 hat and the beta 1 hat used to find beta 0 hat and the beta 1 hat, such that the sums of skewed residual. What is that? SSE, residual sum of square. Somebody said error sum of square, but residual sum of square is, I think, more correct. Is minimized. Okay, so SSE is, in other words, the values beta 0 hat and the beta 1 hat, which minimize SSE. SSE is what? Residual sum of square. Sum of EI square equal to sum of EI is what? This one. YI minus beta 0 hat minus beta 1 hat XI squared. We know the values X and Y. We want to get unknown value, these two unknown values. So, two unknown values. We need to know partial differentiation. If you do not know partial differentiation method, that's okay, I think. Okay. Anyway, somebody who knows partial differential equation, I do not follow that steps. But anyway, the result is the least squares estimates of beta 0 and beta 1 will be like this. This one. And beta 0 hat is y bar minus beta 1 hat x bar. Okay? Simply. Y hat equal beta 0 hat, y hat equal beta 0 hat plus beta 1 hat x becomes the line that best fits n points. We have n points. But this line, residual is this, okay? Residual is this one, this value minus the value on the line. This value, realized value minus the value on the line. That is what? This line is y hat equal to beta 0 hat plus beta 1 hat x. So for each x, there exists y hat value. That value is on the line. So what is it? Residual. Residual is yi minus yi hat, right? This one is yi hat. So they are n residual values here like this. Okay. So sum of squares, residual sum of squares minimizing value are beta 1 hat and the beta 0 hat. So this one is line that best fits n point. N point means values obtained from sample like this, like this. This line is the best fit. Okay. All right, it is not difficult, it is simple, and if you understand this simple material, you better understand regression analysis. All right, that's it today. Thank you. Bye.